If you look back at your, going back to the terminology booklet, let's just look at circle theorem number 8, okay? And what we're looking at is the product of the intercepts of AX times XB. We're looking at AX times XB and CX times XD and seeing if there is a relationship between them. So remember, AB and CD are chords, so we're looking at the product of the intercepts of those chords. All right, if we look at this, in blue, for example, we've got the length of AO is 4.84 and OB is 3.35, and if I multiply those two lengths, I get 16.21, and CO is 3.43, and DO is 4.72, and if we multiply those two lengths, it's also 16.21, which means that AO times OB, or BO, equals CO times DO. Now, I can move them. So, remember, this is, in this program, every time we move the points, we get new measures for AO, OB, CO, OD. So we can see as we move these around and the lengths change, as long as they're intersecting, otherwise it doesn't. Otherwise it ends up outside. So therefore AO times OB equals CO times DO. Okay? That's that theorem. Now, 8 is that the product of intercepts of intersecting chords are equal. So the product of the intercepts, the cut-off bits. See, because AB intersects CD, so they're intersecting chords, but the product of the intercept lengths. So AX times XB equals CX times XD. Okay, that's theorem number 8. All right. Obviously not going to be congruent triangles, all right, because these could cross over at any point. I know I've sort of made them look congruent, but they're not, okay, because remember, this just can move anywhere. But we're going to prove similar triangles. So what we're going to do, so what we want to prove, this is what we want to prove. We want to prove that AX times XB equals CX times XD. That's what we're trying to prove. So we're going to join what? We're going to make two triangles. Join AC and DB. So we're going to do those in another color. Now we want to prove that these triangles are similar. So I'm going to go in triangle. Oh no, I've got to do that. It's all right. So let's go. What have we got? Angle. What about here? What have you got, girls? Angle. Yep. Got vertically opposite angles. So angle AXC is equal to, I'm going to go this way, angle BXD, reason vertically opposite angles. Now, they're not radii. We can't do equal radii. So we're going to have to try some of our circle theorems. So I'm going to go, what have I got? So what about angles at the circumference subtended by the same arc? So I'm going to call that alpha and alpha. So angle CAB equals angle CDB, see? Right? You can put angles in the same segment or angles at the circumference subtended by arc, the same arc BC are equal. So what do you want to do? Angles in the same segment, or I'll do angles at the circumference because it really describes what it is. Angles at the circumference subtended by the same arc, and I'd like to say what the arc is. That's arc BC are equal. So those two angles are subtended by arc BC, and if we turn our diagram upside down if we want, you can also, look, we can do equiangular already, but just for practice, angle ACB, I'm going to call beta, equals angle ABD as well. So angle ACB, and I don't have to call them alpha and beta, I can just put markings. You know what I mean? I can just go like this instead of alpha and beta. All right, so angle ACB equals angle ABD. Similarly as above, with arc or by arc AD. Do you get it? They're subtended by a different arc. They're subtended this way. They're standing on arc AD. Okay? Now, we don't need 3 angles for equiangular, but I just did it anyway. So, therefore, triangle AXO is similar to triangle AXO is alpha, triangle DXB. It's AXC, by the way. Yeah, I'm just doing everything wrong. So, triangle AXC is similar to triangle DXB. Reason? Yep, equiangular. And now I'm going to come over here. Okay, now that what can we do? What sides correspond with which? Girls, we don't want to be using side AC and DB in our ratio statements now. So now that they're similar, so doesn't AX correspond with AX over DX equals, so alpha dot equals beta dot, which is CX over beta dot over BX. Reason? Why does that ratio corresponding or matching sides of similar triangles in same ratio or proportion? And so therefore, just cross multiplying, AX times BX equals CX times DX. And there's your proof. So therefore, the theorem, the product, so from there we went up to here. So the product of intercepts of intersecting chords are equal. And that's your proof. Error here, angle ACD equals angle ABD. I think I said the right thing but wrote the wrong thing, I'm not sure. Okay? Keep writing the wrong thing. AX times BX equals CX times DX. CX times DX. Okay? So if you run over it, AX, BX, CX, DX, you won't write the wrong thing like I keep writing the wrong thing. Thank you, girls.